Welcome to my YouTube channel once again. Today I want to talk about area under the curve. So you can be given a region under the Cartesian plane, but one of the region has been shaded. But this region is bounded by a very straight line and a given curve, a cubic curve, not a cubic, a quadratic curve. So when asked to calculate the area of the shaded region, so this is what you're going to do. I'll take you through step by step. From the first approach, where we're going to find the limits and then find the region using the integration method, trapezoidal method, or the ordinate rule. So stay tuned. If you are watching us for the first time, kindly remember to subscribe, leave a comment, share. So let us start. This region, I'll call it R, has been bounded by a given curve of the function y is equals to x squared plus 3 and y is equals to negative of x plus 5. So the first step, I'm gonna find the limits or the boundaries bounded by that region by equating the two functions. So if I equate x squared plus 3 to negative of x plus 5, then I'm pretty sure I'm gonna find the boundaries. So take this x on the other side. I'm going to have x squared plus x. Then this is 3. If I take negative 5 on the other side, it becomes minus 2 is equals to 0. Then it goes without saying that this is a quadratic equation. So we're going to simplify the quadratic equation by finding the roots. I know the product is the coefficient of x squared and that, so that is negative 2. The sum is positive 1, the coefficient of x, and then the two factors that when I multiply I get negative 2, when I add I get 1. Of course I'm gonna get the answer as negative 2 and 1. So replacing it there, I'm gonna have x squared minus 2x plus x minus 2 is equals to 0. Of course this is positive. And then I'm gonna group so that x into x plus 2. The other side I'm gonna have x plus 2, meaning that I should multiply by a negative of 1. Of course equals to 0. So x minus 1, x plus 2 is equals to 0, meaning this is product of two functions. Then it goes without saying that x is equals to 1 or x is equals to negative of 2. X is equals to 1 or x is equals to negative 2. Since x is positive, then from my interpretation here, of course that becomes 1, and negative 2, it means it is at this particular point. So I've managed to find the boundaries. So the next step, I'm going to solve or compute the shaded region using the first method, which is of course I'm going to use integration method. So guys, using the integration method, I'm gonna integrate. This is a straight line, so integration will give me area under this curve. So if you look at this straight line, from negative 2 to 1, then it means when I integrate from negative 2 to 1 of this function here, negative of x plus 5 with respect to x, of course that's going to give me the area from this region to there. Then I'm going to subtract when I integrate again from negative 2 to 1 of this other curve function, which was x squared plus 3 with respect to x. So guys, up to that particular point, I'm pretty sure my answer is going to come out easily. So let's get on. If I integrate negative of x, of course I'm going to get negative of x squared over 2 plus 5x, but the bounded region is from negative 2 to 1. Of course, when I compute this, I'll start by substituting. If I substitute 1 in this particular function, I'm going to have negative of 1 squared over 2 plus 5 into 1. So this is negative a half plus 5. Of course, I'm going to have 4 and a half. For this other side, if I integrate x squared, I'm going to have x cubed over 3 plus 3x, but the region is from 1 to negative 2 to 1. But I'm not done. Sorry for that, but confusion a bit. For this side, I had just substituted 1. So it means the next I should subtract when I substitute negative of 2. So when I substitute, I'm gonna have negative of minus 2 squared over 2 plus 5 negative 2. Of course, that is it. So computing this, negative of 2 cubed, not cubed, negative of 2 squared is of course 4. 4 divided by 2 is negative 2. Negative 2 minus, so it is negative 2 minus 10, that is negative 12. But remember, I have a negative outside. I have a negative outside. Of course, I'm going to get, so this negative and I have another negative, then it means I'm going to have 4.5 positive, because negative and negative is positive, 12. It goes without saying that the answer is 16.5. So I've gotten the region bounded by this straight line and the x-axis. So for this other side, let me transfer it here. I'll subtract this. So it was negative 2 squared over 2. Of course, that is 4 over 2, and the negative is there, so it is negative 2 plus, this is 5 and negative 2, negative 10, which gives me as negative of 12. Negative of 12, as you can see there. Negative of 12. Okay, solving for this other side, I'll substitute 1 as 1 cubed over 3 plus 3 in bracket 1. Then I'll subtract when I substitute negative of 2, negative 2 cubed over 3 plus 3 in bracket negative of 2. Yes. So computing this one by substitution, I'm going to have this side as 3 1/3. Remember there's a negative, so it's going to be positive of 8/2/3, which of course gives me the answer as 12. But remember, I got 16.5 as the region bounded by the straight line. Now the region bounded by the curve, or under the curve, is 12. If you do the subtraction, then of course my answer is going to have 4.5 square units, of course. Square units. So now solving the same region, but now I want to use trapezoidal rule, which says that when I want to find the area, then I have a half of h, the last ordinate plus the first ordinate, and then you add the remaining ordinate, twice the remaining, 2 up to the last. But what is h? H is the boundary, not the boundary, but the heights of the strips that we're going to divide this area into how many trapeziums. So of course, I'm going to take the last value of x minus the initial over the number of strips, or number of trapeziums that I'm going to use. Applying this, it is 1, which is this one, minus of 2, and I want to divide this region using 3 strips, so that my h now becomes 1, h as the length of those strips. So now, having that, using equation y is equals to negative x plus 5, I need to generate the values of x and y from negative 2 all the way up to 1, the corresponding values of y. Then I'll take them and substitute in my equation there. So if it was negative 2, if you substitute here, then the answer becomes 7. When it is 1, it is 6. When it is 0, it is 5. And when it is 1, of course, it is 4. Applying this one there, then I'll have a half. Area now becomes a half times 1 times, of course, the last ordinate and the first one, if you add them, plus twice the remaining is 6 and 5. Of course, doing that one, the answer now becomes, this is 11 plus, this side is 11, but this side is 22, and now my answer now becomes 33/2, and the answer remains 16.5. So applying the same approach for my curve there, y is equals to x squared plus 3. Then I'll also generate my values of x and y. -2, -1, 0, 1. So substituting x is equals to -2 in my equation, I'll have 7, because that is giving me 4. When you substitute 0 is 3, and when you substitute 1, it is 4. Applying the same, area now is equals to a half times the height, which is 1, in bracket 7 plus 4, plus twice the remaining, which is 4 plus 3. Doing that swiftly, I'm gonna have a half. This is 11 plus 14. Of course, that is 25.5, or 25/2, which of course give me the answer as 12.5. So subtracting the two, subtracting this one and this one, the area using trapezoidal rule is just 16.5 minus 12.5. Of course, that is 12. Then it goes without saying that my answer now is 4 square units. So you realize, comparing the answer for trapezoidal rule and the integration method, we got it as 4.5, but here we're getting it as 4. So guys, for the mid-ordinate rule, we shall do it like this. Let me take this chance to remind you to subscribe, like, comment, share, give me your own opinion about what you think of, any appropriate rule. You can watch my previous video that I did the same of finding the shaded area, but now the area is now bounded by some 2 regions, so you can compare. So as you subscribe, remember to like, turn your notification button on, so that in case I upload a new video, you just get it immediately. So my mid-ordinate rule, we should be told that the area is given by h, and then I add all the mid-ordinates all the way up to the last mid-ordinates. So for my diagram here, for now I'm not gonna use the ordinates, but the middle values. So if you can look at this diagram, from -2 to -1, I want to generate some mid-ordinates there. I'll have -1.5, 0 to 1, I'll have -0.5, and then 0 to 1, I have 0.5. So substituting in the first, our equation was y is equals to -x plus 5, this one. Then the answer now becomes, when I substitute that, I'm going to have, that is 6.5, 5.5, and of course 5. So using that and applying it in the formula, remember my h still remains the same. So area now becomes 1 multiplied by, you add all of them, 6.5 plus 5.5 plus 5. And doing that, of course, you're going to get your answer as course, it is 16.5. You realize it is same all the way, like the other methods. For y is equals to x squared plus 3, then I generate again the values of x and y, negative 1.5, negative 0.5, and 0.5, generating the values. So I've generated the values of y for this function, putting them or combining them by addition. Then I'm gonna have 11.75. So to get the final area, now I'm gonna subtract 16.5, you subtract 11.75, and of course we get our answer using the mid-ordinate rule as 4.75. 4.75 square units. So guys, we have come to the end of this problem. I hope you've learned. Leave a like, comment, share, and most importantly, subscribe. Until we meet again, have a good day.